welcome to the Meltzone Podcast. It is September 2019, Friday the 13th. I'm Tom.
And I'm Stefan. And I'm finally back from Japan, of which I talk a little bit about the experience I had there on my holiday. Tom will also tell us a couple of things on the teleprompter that he printed with his, new big printer that he really enjoys.
Big printers are so nice. In the news section today, for the last time, I do kind of talk about what the MPCNC story has concluded with, and maybe try to give some context for if you've seen the YouTube video, because I don't want people taking that the wrong way. In other news topics, Smoothieboard V2 has launched as a Kickstarter, and we actually think it's a fairly decent board. We talk a bit about the different firmwares that you can use. Rigidink shuts down. They're now a education company and not a filament company anymore, which is a nice turn of events. There's a 3D Benchy printing contest going to be happening at ERRF. And maybe if you stick around, you'll get some tips for getting, a faster Benchy out. And we dissect the Makerbot method ABS announcement.
On the topic of the week, we are going to talk about the non-planar 3D printing hype. So if you guys didn't know, you're usually only printing 2.5 dimensional. Non-planar 3D printing could really actually get you to 3D printing. But yeah, we will give our thoughts on if it's really feasible, where it is feasible, and the first experience that Tom had, trying it out on his Linux laptop.
Will we see 4D printing next?
Oh, I have 4D filament at home. On the questions, we just briefly talk about filament drying, once again, filament dry boxes, and where it is necessary or important to dry your filaments. If we still earn money with this podcast with YouTube Premium. And last but not least, something that we had been talking about last time as well, matching stepper motors to your stepper motor drivers.
Stefan, how was Japan? You're back.
I'm back, finally, after 4 weeks. Yeah, well, I have been in Japan for 3 weeks. It was really, really nice. So, yeah, I was telling you already that I have been to Asia already a couple of times, but I really enjoyed being in Japan. Totally honest. The only thing I didn't really enjoy that much is the kind of a long flight. So 16 hours to Tokyo and 18 hours back. Yeah. It's rough.
The flight in those like high-pitched, what are those for?
High-pitched?
Like for birds or to disperse the youth, which did probably work.
The rodent repellent ultrasonic devices all around Tokyo. That was horrible.
Ultrasonic.
Big
air quotes there. Yeah.
Yeah, one of the first. So yeah, maybe let's get back to the beginning. So yeah, I've been 3 weeks in Japan. We were in Tokyo. We were in Hiroshima. We were on Bunny Island. We were in Kyoto. We were in Osaka. And then just like for 2 or 3 days in the mountains in like a Buddhist monastery or something like that. And then back in Tokyo. It was cool. It was really nice. Just as always, I was really jet lagged when we arrived there because
you've got 3 weeks to adjust.
3 weeks to adjust, but it's still rough in the beginning, and you're just tired, and then you are at the airport. It has like 40 degrees outside, and you're still wearing your long pants and thick socks and everything. It was rough, but we didn't book a really bad hotel to start with, just because we knew, okay, if you're already like really jet lagged, you don't want to end up somewhere where you don't feel comfortable. So
no pod hotel for you?
Sorry?
No pod hotel for you? You just get your sleeping pods?
No. Actually, well, we weren't in the main travel time. There were lots of Chinese visitors there, and Koreans, and even Japanese. people traveling around. But I think the high season in Japan is like spring with the cherry blossom season, and then in fall again, where all of the maple trees change to different colors. So it was crowded, but it wasn't that crowded. And the hotels, they weren't cheap, but they also weren't like horribly expensive, to be honest. So yeah, we had quite a nice hotel at first, and we paid around, like, was it 120 euros for 2 a night, which is kind of okay if you're like directly in Tokyo.
If you have a nice hotel and everything.
Yeah, but then, sorry.
Yeah. Yeah, but keep going.
Yeah, but then the first day when we were looking for breakfast, because I just couldn't help myself eat rice and miso soup and beans for breakfast, I just need to have something sweet in the morning in my coffee.
Is that the traditional thing?
I don't know what's like totally traditional in
not
Japan.
Like traditional. Not every Bavarian has Weißwurst for breakfast either, but
the thing that is usually eaten in the morning, I think in Japan, is like rice and a bit of soup, and like I have a feeling that the leftovers of yesterday, so like be it beans or omelette or things like these. And I'm just a sweet breakfast guy, so yeah, we were looking.
You should visit the UK sometime.
Well,
they would disagree.
Well, I can start with having like bacon and eggs for breakfast after I had my first like peanut butter jelly sandwich. Right. Then I'm totally fine, but I need to have something sweet beforehand. Well, anyway, so we were looking for just like a cafe or Starbucks to have breakfast the first day, and we ended up in a really nice cafe, but they had just in front of their door one of the horribly loud rodent repellent ultrasonic things, which is just exploding everyone's heads there, who is still able to hear like 19.5 kilohertz frequencies.
Yeah, he showed the spectrum analyzer screenshot. I mean, it's amazing that you're still hearing like almost 20 kilohertz, but
it's horrible, and it's everywhere in Tokyo.
Yeah.
So those things are really directional. So the thing is, you walk around a corner and then just your head starts to explode. And I don't know how people can bear that. Because
I tweeted that you was like, hey, at least after 2 days, you won't be hearing it again because you'll be deaf at that frequency.
Yeah. No, it was really unpleasant, to be honest. And they have that quite often there. But I have only seen, I think, one rat on my whole trip to Japan. Almost.
It works, right?
Yeah.
I guess.
No birds. I don't know if the birds were also repelled by the device or if they're just extinguished by some other, I don't know, thing.
I mean, I feel bad for dogs and cats because they tend to hear those frequencies really well.
Yeah.
Yeah. Anyways, did you do any like makery hobby stuff there at all, or was it really just shut off for 3 weeks and let everything pass by?
I thought about that because there's quite a big maker space in Tokyo, and I thought about just like getting in touch with them and asking them whether I can just say hello. But then I thought, okay, it's holiday, stay away from work as much as possible. One really interesting thing, which was kind of engineering related, was like visiting the, what's it called? Team Labs. Just give me 1 second.
Googling during a podcast.
The Team Labs Borderless exhibition in Tokyo, which is kind of an art exhibition, but the art is not like paintings. It's lots of audio-visual things. So you have a room with 1,000 RGB lamps in there, and they are changing colors in a really nice pattern. You have a room which was huge, like 20 by 20 meters, where millions of LED strips were coming down from the ceiling. So you have a monstrous 3-dimensional screen in there, and they were showing really cool things in there. So like fire which was burning there, or waves which were going through the room. One room had like 200 of those 3-dimensionally controllable show lights in there, which you also see if you go to a concert or something like that. Yeah. And they were all working together. So, for example, they were tracking a point in the room. So all of them were kind of focused on one point in the room. It was really awesome to see. So that was really nice. That was really nice. And really, to everyone who is visiting like Tokyo for once, go there. It's just awesome to see. It's kind of crowded, to be honest, but the exhibition is really nice. Go there as soon as early as possible, because, for example, the thing I was telling you about with the lamps that were changing color, it's called, I think, the lamp force or something like that. Lamp, not lamb. You had to wait there like 1.5 or 2 hours in line just to get into that room for 2 or 3 minutes, and then you're kicked back out again.
Okay.
So yeah, it was really cool. No,
it's on vacation. You have the time. You don't have to be anywhere.
No. Public transportation was great. So, well, you maybe know it from Germany, but the trains are seldomly on time. And in the 3 weeks we were in Japan and we were using lots of public transportation, every train was like perfectly on time, like to the second on time. Yeah. Besides one that was kind of delayed because of a thunderstorm. Public transportation is awesome.
That's not like, the local transportation. That's a long distance train.
Both. So public transportation in the cities was really nice, but also the Shinkansen train, which is the bullet trains they have in Japan. That was also just like always spot on. And we were already kind of scared because we had some transit times from one train to another, which were just like 2 or 3 minutes. But that's totally fine there.
What if one train is late? No, it just doesn't happen.
All Shinkansen trains in Japan together have just around 5 minutes of delay every day, summed up.
Wow.
Tell that to the Deutsche
good,
Bahn.
Yeah, where trains sometimes just don't even happen. And that's not out of the ordinary.
But the thing is, their bullet train system, they have specific rails or like dedicated rails just for this type of train. So they don't interfere with like normal transportation between
cargo
and stuff like that.
That might block up rails.
That helps a lot.
Sure does. So I guess you did enjoy that. It sounds like it. You enjoyed that trip very much.
Definitely.
Very nice. Yeah, I still need to check out that entire Asia region. I've not made it very far into that yet.
We need to go to Shenzhen once and visit like all 3D printer manufacturers there are on the planet.
Yeah. I mean that entire area is massive.
Yeah.
That would be fun. I think some folks that we write with on Twitter actually live in that area.
Mm-hmm. I think it's interesting. I've never been to China before, but I have heard people, which I talked to in Japan, that have also already been in China, that they enjoyed Japan way more because of the cleanliness of the cities, the kindness of the people, the just overall sense of like, how do you say? It's just great being there. The people are nice. They're shy, but they're really nice. English is quite hard there, but it's enjoyable to be there.
All right. Well, I guess then Taiwan. Mm-hmm. Not quite China, but not quite Japan, but still supposedly the people are nice there.
Yeah.
Oh, well.
Yeah.
Should we move on? You're getting me all envious. I didn't get much vacation, but...
you need to go on vacation. I even thought about really deinstalling Twitter on my phone. I actually already installed like YouTube Studio and all of the things that were related to YouTube from my phone. I just had it on my iPad. So at least during the day when we were just on the streets, I didn't fall into the trap and check comments or things like these views.
Yeah, but I feel like I've gotten good at that too, where it's like, okay, you know, I check comments when I want to check comments.
Yeah.
But like these last 2 days, I've not really checked comments intentionally because, like, you know,
Yeah, understandable.
don't need to. Cool. That was your big project.
That was my big project for the last 4 weeks or 3 weeks. I'm now getting back into like also working for YouTube related stuff. But what have you been up to?
What have I been up to? We're going to get into more of that in a second. But first, let's finish off the project section. The first episode that we did on this podcast, where we had the topic of the week, of the bi-week. We should rename that section because it's not every week. Big printer or fast printer? And I've been very much enjoying my big printer, the Raptor 2.0. I mean, it ain't perfect. Not by a long stretch, but just having access to a printer that does 40 by 40 by 50 centimeters is just eye-opening. It's just like, oh, I can print that. Like, no problem. It takes a week, but you can print that. That's really nice. And I've been printing a teleprompter completely on that printer. I had a job that I was filming where I needed to bring a teleprompter, and my current one, or my old one, that was just like a particle board screwed together, like the angles weren't even right. I didn't want to show up with that. So I printed a new one inspired by, you were just Googling a second ago. Now I have to search for the email. By a guy who sent me a small... Daniel, yes. Thanks for looking that up. Who sent a... Did he send you one too? No.
He also sent me one.
He sent you one too, right.
Yes.
So he sent a small, like, what is it, 7-inch screen size maybe. And most, Stefan, you have yours handy. That's perfect.
Wait a second.
And I mean, I usually use like a 12-inch laptop screen. Yeah, that's the one. For my teleprompting needs. And that one just, I mean... was a great idea. It's really good that it's printable at that size, but I needed a camera mount, I needed a larger screen, I needed a proper way to hold the screen. So I printed one, and it turned out beautifully. So that's the one. That one is very small.
Yeah.
So I printed a larger one, and it's just, again, the project itself. I might make a video about it because it's a nice project, and you can very easily do it yourself, but. It just proves that point again, that having access to a printer that can print large, I feel like is so much more enabling than having access to a printer that can churn out parts quickly.
But would you have really needed the 400 by 400 space?
I think 350 would have done.
Okay.
Or 300.
Is it really that big? Because I couldn't judge from the picture that I saw on Twitter.
I mean... It uses an 11.6 inch laptop screen, so 12 inch. So it's like a decently sized screen, and like the entire hood that the camera is looking through is it's over 30 by 30, I think. So maybe I could have done it on the CR10 if I really would have squeezed it in, but it's, just designed big. It's just so nice.
So I have been using a teleprompter in the past for a couple of videos until I broke the glass. The thing that always bothered me when using it, I was just using a cheap like picture frame glass that I got from the hardware store.
Yeah.
That you get all of the letters twice because they're reflected on the front side and on the back side of the glass. Can you get around that, or how do you make it usable better?
What I thought you were going to say with that picture frame glass is that it distorts the image and and degrades the image quality, which picture frame glass also does because it's not flat. It's really wavy and has different thicknesses. So you get, if you just use like spare picture frame glass, that's also the problem there. But like the double reflection is also something that I'm dealing with.
Yeah.
I just have a really large screen and a relatively thin glass in there. So they're relatively close together, and it doesn't really matter much. But what you usually get for a teleprompter needs is I guess a tinted, not glass or polycarbonate or acrylic, but with a clear acrylic sheet and a semi-mirror reflective film on top, you use for like window tint.
Okay.
And that does cut down on the light that actually reaches the camera. Mm-hmm. But it also cuts down the double reflection that you're getting from diffraction on the back of the glass.
Okay.
Because you get like if it has to, the point where it refracts on the backside, it has to travel through that sheet twice. And the reflection up front is just directly on the surface.
Yeah.
So that really cuts down on that, but I don't need it. My screen is big enough. And if you use the right font, if you use the right font weight, it really is okay. It's really, really readable.
Okay, cool. Yeah, I need to get this one working again, because staring at a piece of paper which is above the lens is just sometimes looks a bit disturbing to the viewers.
Yeah, well, I guess it's... Do people actually comment on that?
They did comment on that. I think in the beginning where it stood way closer to the camera. So nowadays I try to just get away from the camera a little bit more, that the angle difference between the lens and the paper I'm reading from isn't that big. But still, it's not a good solution.
The first sort of teleprompter kind of thing that I used to do, and you can actually see in my early videos that I had the mouse scrolling along, is I just took my phone and mounted it above the camera and had a Google Doc open. So I'd have it sideways and just scroll through. So I was always looking slightly above the camera, which looks weird, but at least it wasn't that far off. It was always just that distance. And that actually worked surprisingly well for a while.
Yeah.
And then I built myself some sort of teleprompter. So
yeah, well, you're standing in front of the camera way more than I do. I usually just use it for like the outro. But yeah, I don't know. In the future, I really envy you, or I really envy all of the people that can just get in front of the camera, talk about things, and then use that like for 90% of the video, and then just add a bit of B-roll at the positions of the cuts where you just screwed up your line.
Yeah, well,
it's training. It's training. You've been doing it for 5 years, 6 years.
I think longer than that. If I look back when I published my first video, which is actually still online, it's still very, very.
Oh man, I also watched mine just a bit ago.
Oh god. Yeah, but I think we've improved. I hope we did.
Definitely.
Yeah.
After actually my first video, I started writing scripts, because the first one that I did, I was just speaking in a lavalier mic, just random things, and it sounds horrible. I'm kind of embarrassed of it, but I also don't want to like remove it from the channel, because it's a bit of history.
Hey, the what was it, MKBHD update, the V5
the V5 update,
yeah, that went viral again these last few days. It's like, who knows? You know?
At some point, you're gonna make millions from your first video.
Yeah, right. Ancient history.
Yeah, definitely.
Right. Let's move to the news section. This topic that has been looming over everything so far. The MPCNC.
Yeah, this was quite a big project you did when I was in Japan. So you streamed for almost the whole week, every day.
I think it's 7 or 8 videos total now. One with like the overview, and then like daily 1.5 to 2.5 hour builds. And let me use the podcast here for those of you who are listening to the podcast, to give you a bit more insight and like my more detailed take on things. Because I feel like in a YouTube video that's hard to bring across. I've made some notes here. First, I don't hold any grudges against Ryan. I can totally understand his position. I've just decided that the project is not for me. I don't like the way how this entire thing has turned into, well, screw that guy, screw this guy. That doesn't help anyone. And Stefan, we were talking about this before we started recording here. Is I'm very much aware of like the leverage I have by being a influencer, as much as we both love that word, by just having such a range.
I think reach.
Yeah, but by having people who will actually watch my stuff, that there is a bit of a responsibility there. So, let's back up again and look at what was kind of the core points, I guess. Is it a derivative? Is it protected by copyright? And like, what is the right thing to do? and because I don't want to answer that, I don't want to fight that through. I don't have the energy, nor do I want to turn this into a shit show. I was just like, okay, that's that.
Yes.
Do you have? You were gone, so
I was gone.
Catching up on things. Do you
I have seen your Twitter post where you first posted the part, and then just a day later or so, I've seen, oh yeah, I removed it again. And I thought, okay, why did he do that? But I didn't read like the whole conversation. Your video cleared a lot of that up.
Which, I mean, you asked me, hey, why make a video about it at all? That was the reason why I made that last video about like, hey, this is what the situation is. This project is ending for me. I didn't want to just leave this out like hanging. The machine is kind of not cutting well. Like, why are you stopping now?
Because you would have liked to continue working on the MPCNC, wouldn't you?
I mean, I did.
Yeah.
Yeah.
And improving it for your own purpose, because, well, I've seen the chattering issues. I think it's a nice design. I think it's a nice idea. I think it's also a nice showpiece just to show what you can do with 3D printed parts. That you can even build a CNC router that might be able to cut aluminum. So yeah, I'm kind of upset to see that you stop the project, because I think you could have improved the machine. You could have shown the community that something like that exists, and even motivate other people to build one on their own and improve the project and make the machine usable for even more people around.
Yeah, I mean, I could still do that, right? I could still publish as NC and just be like, okay, that we're going to do it that way. But again, fighting against windmills and having that backlash is not great. Now, there were also a few discussions on like, hey, your design mod, like, why are you even doing that? Like, it's not even better. Like, you should stop. Or I've seen in the V1 forums where someone was like saying, hey, your belt trap, or that belt trap that Thomas is showing, that will never print. But I think that's like an entirely different discussion, whether the parts are actually an improvement or not. And I don't think it changes anything on like who can do what with which designs. Yeah. I mean, again, I can totally understand Ryan's position. He obviously, it's his job, it's his income when he's selling part, and he's afraid that, when there are open parts that anyone can print and sell, that might impact his bottom line. As in, somebody else will start taking the designs and selling them on eBay, which apparently has happened with the first version of the MPCNC. Or what is it? People will use third-party parts and then come to Ryan for support, which I think is all. I mean, it all has two sides to it. Like being more widely spread. I mean, of course, bringing up like, hey, Prusa obviously is the big one. It's an open source business that is extremely successful. I've seen in the 3D printing world, that is exactly what has been happening, and that has in fact been encouraged by the community with like mental parts being sold on eBay for, I don't know, I think the early ones were like 150 euros or so. Now a set of Prusa parts is like $25. That all plays into it, and of course it's harder if it's at this point, at this like earlier and not as widespread point. It's much more of an impact on someone's bottom line if all of a sudden someone comes in and has less effort to put into producing a set of parts, because Ryan also designs them, supports them, and then prints the parts and sells them, and that's his income. Like I get that, I understand that, but still.
Yeah, I think it's good that you have shown your reasoning why you stopped working on the project, because otherwise maybe people would just have like bothered you all of the time. Hey, when is the next video coming out, and you need to explain it all the time where you stopped working or just don't respond at all.
Yeah, or there's like theories coming up of like, hey, that's what actually happened, and no.
Yeah, as I said, I think it's really unfortunate. I would also really have been quite interested in the design, but yeah, it's just as it is.
I guess what we can take from it is at least there's like a lot of discussion now going on with a lot of constructive input on like what can copyright protect, and like that entire, okay, is this a derivative and what is it? All that there's a lot of actually very good information and correct information being put out there right now, and I think there's definitely a need for that. Because right now everyone just assumes, okay, I have this part, I slap a license on it, and that's set in stone. But it's not that easy. There's reasons why there are lawyers specialized on copyright law. And yes, I was in this entire discussion, which I have, after the video, kind of stayed back from. I've intentionally been pushy. Like, I'll definitely admit that, because of this outcome, that there is now a discussion happening on what actually is the like legally allowed and what is the right way to do things. So I think we come out smarter than we went into this. I would have liked to continue, but again, like I said, it's just.
Will this actually change the way, or will this change the projects you are working on in the future? Will you ask yourself in the future, is this something which is really worth working on, or might there be the same things happening as with this thing right now? And you actually you were aware of the license, and you were asking Ryan before you started with the video series that he gives you the approval to use kind of his design in your commercial videos, or your video.
Not explicitly. So last year's Murph, I interviewed him, and the video is still up on the channel. And we ended, hey, should I build one? And he's like, yeah, you should.
Okay,
that is what I consider implicit.
Okay.
Implicit approval or whatever for me to build this thing. And he's also said on Twitter that he's fine with me making modifications, using this in videos. He would even be okay with me selling the parts, which is actually something that is outside of that original license, because he's like, the parts are NC, the parts are non-commercial. So that is actually something that he'd be giving to me as an approval, that I can now sell these parts. And again, that is not something that, if we consider the part a derivative, that's not a right that I get.
Okay.
As always, I have no interest in selling parts. I'm strictly so far been staying out of hardware, because like hardware has such a rat's tail.
Yeah,
Pandora's box effect on it. Once you open that, you're in the deep end. So I have no interest in selling parts. But yeah.
All right. So other news. This
yes.
was kind of the thing you were kind of working on for the last weeks. But you have put something with the Smoothieboard V2 Kickstarter in the show notes.
Yes, open source
Tell me
hardware.
about it.
So Smoothieboard. I've been using Smoothieboard for the last years, on and off. I've been doing projects with it. And it's a nice board. It's like in that trifecta of having Marlin boards, having Do It, and having Smoothie. It's like somewhere in between. Like it's a powerful 32-bit system. It's good hardware, but it's slightly proprietary hardware. There are some third-party boards that Smoothieware runs on. It's an interesting system. It's really modular. And Arthur Wolf, the creator of the Smoothie project and maintainer of the Smoothie project, has launched the Smoothie Kickstarter, Smoothieboard V2 to be specific, which is basically a new board, a new generation of board. 3 of them to be specific, with now on the beta versions, Trinamic drivers, which I guess is a given on any new board these days. And just overall, more features, more powerful hardware. So that's live, and the pledges start at €85 for the V2 Mini.
Okay.
So the Mini is kind of like a Rambo Mini alternative, I guess.
That doesn't have TMC drivers.
That one does not have TMC drivers, that is correct.
How does a Smoothie board actually compare to, like, for example, a Do-It?
Hardware-wise, so I think with the V1 Smoothieboard, the Do-It has slightly better hardware. Though, I mean, if you have a well-designed board, like there's not much difference in hardware. Like, what is it going to be? Okay, what drivers does it use? If it has pluggable, like that thing's smooth, that point's smooth. What MOSFETs does it have, and how much current can it handle? And like what protection features does it have, and expansion features? And hardware-wise, I've always thought the Smoothie board was actually pretty good. And I mean, for me, it's always worked well. I think the V2 is pretty much in line hardware quality-wise with Do-It. Or is it Do-It 2? Yeah, that's the current generation of Do-It boards. So it's a really good board, I think. I mean, I've not used it yet, but it looks to be just good hardware. If you're okay with Smoothieware, try it out. Try it out. How can you try out Smoothieware?
If you don't have a Smoothie board. This is actually one of the questions I wanted to ask you. So this does use a different type of firmware than the Marlin firmware that probably most of us have running on our printers. If you have a Chinese printer, which was released in the last 3 years. There's Smoothieware, there is rep firmware, or how's it called?
Yeah, which is what's running on Do-It.
There's Marlin, there is Repetier.
Yeah, Repetier firmware. There's also some proprietary Chinese firmwares.
Okay.
For example, what we've seen on the Monoprice Delta Pro. But that's an ecosystem of board and firmware and all that. So as in how does it compare? As in features or the way it works?
The thing I was asking myself, is there really the need of having like that many different projects or firmwares? Is there the necessity that they all exist like next to each other, or wouldn't it be better if like everyone is putting his development money or efforts into one big firmware, which is then running on all of those boards?
Yeah, I guess what you still have to consider is Prusa firmware is basically a fork of Marlin at that point. It's its own version of Marlin. It's not really related to mainline anymore. So we have those 4 versions. I mean, right now they're all kind of specialized on different things. Marlin traditionally is the only one that runs on 8-bit boards, maybe Repetier, but that's closed. Smoothie or RepRap firmware does not run on the old Atmega chips. But to be honest, there's really no reason to use those anymore, aside from being able to plug it into a computer and flash it with Arduino. Because those chips are, feature-wise and performance-wise, really bad, and they're really expensive. Like they're one of the most expensive, or the most expensive bit to an electronics platform. And 32-bit chips are actually cheaper. That's the other thing. So yeah, that's Marlin. Then Smoothieware. Smoothieware is kind of its own thing for some reason. And then Do-It obviously has all the features, like everything just in there. Like if you look at G-code support on the RepRap wiki, Do-It supports them all, basically. Okay. So that's the powerhouse. That they all kind of cater to different, areas of the market, I guess.
Okay. Because I am not really deep into that topic, and I was always asking myself, okay, what benefits would I have if I would exchange my old 8-bit, I don't know, board with a Do-It, for example. Of course, I get smaller microstepping, but also feature-wise, does it support features that would improve the quality of my prints, or would improve the printing speed, or things like this?
Yeah, so that's what Do-It is all about. Just by having that extra compute power, you're never going to run into like buffer underruns where your board has to pause for a second. The thing that it has a really powerful web interface built in. Yeah. That is, I think, a huge pro for Do-It. And they all can do sort of different things. I feel like Smoothie is by far the most flexible one of them, because you can configure like every pin to be like an input for this feature block and trigger that, and it's almost its own programming language. Marlin is really pushing into that. Okay, X, Y, Z axis, and then you have the alternative config for Delta, where you have your, I think it's also X, Y, and Z in Marlin, where it's really, you have these monoliths of a configuration, and then Do It kind of does it all again.
Okay.
But yeah, on the, I mean, if you look at what Prusa's doing with Marlin on an 8-bit board, that is incredibly impressive. But there's also the thought, okay, what could, with this amount of development effort, what could this be if it was a 32-bit board?
Yeah.
If it had more flash, more RAM, more everything.
Because you spend so much time in just optimizing your code that it fits on the microcontroller, that it runs properly on the microcontroller.
Yeah.
Of course, Joe has been saying several times that why do we need a 32-bit controller? See what we can all do with the old 8-bit ones. But I'm also thinking about, what's the downside of having a 32-bit controller? It's cheaper, it's more powerful, I don't know if it's probably a bit harder to implement.
It's a new, not really, because with an 8-bit, I think Marlin is going into the direction of actually optimizing some bits with assembler programming, which is like the highest echelon of programming languages. And I mean, with a 32-bit board, like, you have just so many more cycles that you can use for computing stuff, and you have so much more performance per that one clock, or that one clock tick. You don't have to spend time on over-optimizing stuff. And that's what we're seeing with like game programming and apps programming on desktop computers, or your regular x86 computers. It's like, oh, you use this framework, you use Python, you import that, you have a ton of overhead. Like, you could probably do it with 1/10 of the compute power. But just getting there and getting something that works well, and maybe spending a bit more on hardware is possibly the better trade-off than spending, a ton of time and not even getting that far, but being able to run on like the smallest possible hardware.
Okay.
Like these processors, again, the 32-bit chips are actually cheaper than the Atmega 2560 that's being used. So you basically get that for free, that luxury of not having to do everything in a hyper-optimized way.
And well, we have seen 32-bit controllers becoming way more popular over, I think, the last year, because even all of the new Chinese printers, they start to be shipped with 32-bit controllers. I don't know, either because it's a marketing gimmick, or because you don't need a separate board for the LCD from time to time. You can do all of that directly on the board itself. You have web capabilities, connectivity, and all of that stuff, which you did not have before, or where you need to have specific separate electronic parts that handle that specific task.
Yeah. In fact, the Raptor is already running a 32-bit board, just running Marlin 2.0, which actually is not in its like production-ready version yet, so it's still beta. And it does still have bugs every now and then. But recently, Big Tree Tech sent me their SKR, the Skrr board, the 1.3, which is like a €25 main board with a 32-bit processor. That runs Marlin 2.0.
With drivers or without?
Drivers on top, but if you just get a Lego drivers, those are $10 for 4.
Yeah.
So, like, really not relevant in the price. But that is just amazing. Just getting rid of that Atmega and putting in a 32-bit chip, you suddenly have a really cheap board that maybe wasn't even possible with an Atmega.
Yeah.
So... yeah, that's nice with 32-bit. And yeah, one last note on firmwares. I believe the current Smoothie board with the LPC 1769 can possibly already run Marlin, Marlin 2.0. I think like the standard cheapo 32-bit processor is the LPC 1768, which the SKR also uses. The new one uses the LPC 4330, and I just Googled a second ago. I think there is support coming up for Marlin. So you're going to have that option of, hey, do I actually want, with this hardware, do I want to run Marlin or do I want to run Smoothieware?
That's pretty cool.
The project that that I want to do. So that is in fact very nice, yeah.
But it also maybe makes the development of like things like Marlin more complicated, because before they only had to develop for the Mega, how's it called? I'm already getting down this Friday.
At Mega 2560.
At Mel.
you still seem jet lagged.
Well, I've been working all day, so yeah, first week of work. Well, okay, yeah.
So
I think it makes it. I don't have any insights there, but I could imagine that it's more complicated making a piece of software work on many different like processors than just like tailor it for one.
It creates a bit more upfront work, which is why Marlin 2.0 has taken a while and it wasn't like in there originally. But Marlin 2.0 now has a hardware abstraction layer. So the actual functional code doesn't see the hardware itself, but it just says, okay, I want to turn on this output, or I want to turn on the output that is controlling the heater. And then the hardware abstraction layer looks at, okay, what board am I using? That's that pin. Okay, what commands do you need to use for this board? And that's all invisible. So that's all written once, and well, plus bug fixing. But like the actual functional stuff builds on top of that. Just like, Windows runs on an AMD or an Intel processor or even on a Pentium 4. So because it has that hardware abstraction layer.
Cool. All right.
Processors isn't really a good comparison. Maybe graphics cards. Let's go like that. Sad news.
Sad news. Yeah, Rigidink shuts down. So yeah, I think this was a week ago where Rigidink announced that Rigidink shuts down the production of filament.
Yes.
I think the right way to put it. So Rigidink is a UK company.
Yes.
That has been in the filament and 3D printing market for quite a while. I actually have never been using their material up until like a couple of weeks ago when I got a roll. Yeah.
You're missing out. It was actually really good stuff. I did a few tests on Halloween with the materials, including the ASA, I believe, was from them, which was actually one of my favorite materials. I had the red stuff, or the red ASA, and it's just... They made really good materials, not just, nicely packaged, good tolerances, but it was also good base material. That was the other thing. So I always liked their stuff. It was on the pricey side, to be honest. It was not the cheapest material. And I believe that was one of the reasons why they had to shut down in the end, because, competition, right? There's mass manufacturing happening of filaments now. And if you're just a 2-man, 3-man team, it's hard to keep up with that if you're doing specialty materials.
Yeah. Well, you have to put out tons of material if you're just making like a couple of dimes per roll. So, yeah. It's getting harder and harder. Also, all of the filament which is coming to our market from China, even though there are still plenty of filament manufacturers around here in Europe, which I sometimes ask myself how they are really able to stack up against the Chinese influx. But I think it's still sometimes, quality of the material, and you know what you're getting, and it's more repeatable and things like these.
And I think a part of it is also if you're making like your basic materials, like a PLA, you can get the raw materials for pretty much the same rate as like a Chinese vendor can. And the thing from China is always shipping is one of the main costs. So if you ship up just a 1 kilogram roll of raw material from China, that is going to add considerable cost to your final sales price. Instead, manufacturing local-ishly, you don't have that. You transport your resin in bulk. That's a lot cheaper. So there may be a business case for just doing like, probably not like Rigidink did it with like super super nice materials that are sold at a premium, but just doing like normal stuff that people are actually going to print with. And I think that's how, for example, Filament is staying afloat. And they seem to be doing pretty well.
Yeah, because they have really competitive prices. You pay like the $20 per kilogram.
$20 per kilogram for the nicer colors. You pay, I think, like 22 or 23,
and that's shipped. Or
is it? Share? I think you get free shipping if you buy like 4 or 5 spools.
Okay.
So basic, normal, good, consistent material. You know what you're getting. I think that can still be a market, but I kind of miss Rigidink. Now that they're not here anymore, because they had those specialty stuff that I really liked printing with.
Yeah, but they're not shutting totally down. I think as I have read it, they are continuing with like educational stuff towards 3D printing.
Yeah, so their first product, I think, is a complete printer debugging guide. That they're printing on a e-learning platform, or publishing on an e-learning platform. I guess they know their stuff. That's for sure. They know how to run a printer and how to diagnose prints. So that's their first new product, I guess.
Yeah,
it's interesting that they're competing with us now.
Yeah. And we're giving away our our knowledge for free. No, I'm really interested to see if this is a business model that pays out for them, because the guide is $15. You have to sell a ton of them.
Well, it's like the internet, right? You don't have you don't have to run a sales pitch for every single one. It's we produce it and it's on there. Yeah. I think 5 years ago or so, I produced a course with Video to Brain, which is now LinkedIn Learning, and I'm still getting payouts and commissions from that. It's not a lot, but it's like every quarter. They send me like 60 euros or something, and I'm like, yay!
There are a couple of episodes of your course I think available for free, and it's really funny to watch them with your Bavarian accent.
Yeah, because that is a German course. That is not.
That is a German course, and there are a couple of other YouTubers around that also sell 3D printing books. There is 3D Printing General. He has one. Yep. Chap doesn't. The 3D printing professor, he also has one, and even a couple of more. And they're selling their books, I think, even over Amazon. So they might be making a dime or two.
Or it doesn't even have to be like actual books on the subject. God, what's his name? I'm bad with names. I like to make stuff. Yeah. What's his name? God damn it.
Bob Craiglet.
Yes.
Bob.
Yeah, Bob. He has a book on, I think more on the, hey, how did I, get this entire thing running? How do I now have a business that is, me being able to make whatever I want? I think if I don't read enough. I should probably pick that up, I think.
Okay.
Would be nice. So, books, as I've heard, are a lot of work and don't pay very well. But maybe if it's like an actual factual, guide, or a, getting started basics kind of thing, maybe that works.
Yeah, I hope for them. They've been,
for sure.
Well, they've been nice to you, sending you filament. They've been nice to me, sending me also a roll of filament. Yeah. And a really, really cool kitchen knife. So yeah.
Oh yeah.
I hope it works out for them.
For sure.
All right.
Let me just make some notes here. How are we doing on time? We are at 54 minutes.
Yeah, we need to get a little bit faster. So you are going to the East Coast Rep Festival, which is in 3 weeks.
ERRF. 3 weeks? Is it 3 weeks in a month? I actually need to check my calendar, but that. Soon-ish. And they are having a 3D Benchy printing competition, which I
think is pretty cool.
Yeah.
So
Who's going to talk about this? You or me?
You.
Me. Okay. So what they're putting up, and I think they've asked me to be on the panel for that, judging other people's prints, because apparently I'm good at that. Is they have, quote, print the highest quality 3D Benchy in the shortest amount of time. So they've got 2 competition brackets categories, 30 minutes and 60 minutes. So you get to print a Benchy, and it has to be full size, I assume, because otherwise a Benchy doesn't really make sense. And you have to finish it in 30 minutes. I think like heat up times don't account for that, but like actual printing time. So you get 1 filament and you have to print it on site on Saturday at ERRF.
So everyone gets the same filament.
Everyone gets the exact same filament, yes. Okay. No special high flow Faberdashery filament that you can just squeeze out. Just normal, same for everyone. And that's interesting because, for example, no model modifications, that's a requirement, but slicing mesh modifiers are allowed. And the only category that they're judging on is quality. Not, is it strong? Is it, I don't know, what color is it? Or it's literally just how good does it look? So, Stefan, what would you do to get a model printed as pretty as possible in the shortest amount of time?
It's really hard. I thought about that, and there are different approaches you can do. So, I don't know, reducing the amount of perimeters you use. Maybe just use 1.
But then you
make sure that
is
through. That is the question. If you maybe print the infill first, printing at higher temperatures and faster, having a lot of cooling. I thought about the slicing mesh modifiers, and in the short amount of time I had to think about that, I'm not 100% sure how this might be helping you. The mesh modifiers could be used to change the amount of infill or perimeters at specific locations, but I don't know, you wouldn't be using that much infill in the first place.
Well, I mean, you'd want to get a nice balance between having your top layers cave in and not using much material in the infill. So, or using too much material in the infill. So I think just having actually going off of the original geometry of the 3D Benchy, having what Cura does actually natively without mesh modifiers is having staggered infill. So the closer it gets to the top surface, the denser it gets. So I think that would be a huge opportunity there. Also, things like being able to set speeds for certain areas very precisely. Knowing exactly how slow you need to go for your filament to start curling. Like, for example, being able to, where it prints the bow, where it usually curls up at the front, or the chimney kind of melting down, being very precisely able to control speeds and temperatures possibly for those sections. I mean, there's a ton of optimization opportunity.
And it will be really interesting to see with what other ideas the people come up, what slicer they were using, what machine they were printing on. It's probably a Delta can print faster than a Prusa.
But then the Delta would be a Bowden, so what's the trade-off there? Yeah, I mean, it's for sure going to be tough to judge quality, whatever that means. How do you judge a caved-in top layer versus infill poking through? Like, is that the same? Is one worse than the other?
I was actually talking to Paul Poxtelis about that, and there were ideas shuffled around what could be done. And I currently, until I think next week, still have my 3D scanner right here. Could you use a 3D scanner to judge the deviation of the printed part to like the nominal STL model? Is that really something which is related to something that is related to quality? I don't know. Does quality even degenerate if like small outliers, if you have blobs on the surface? This probably degenerates the quality way more than if your part is a little bit under or oversized.
Yeah. And like, is layer height even something to consider? Like, is a print that is printed with 0.3 a worse quality than one that is printed in 0.2. So I think quality is not something that you can like actually metrically measure. You can't point a 3D scanner at it and say, okay, here's the standard deviation for the entire surface, and we're at 0.05 millimeters, and that's better than the other one that's 0.007. Because how do you judge like smaller surface imperfections? Is that worse than having continuous or small imperfections everywhere than having like one large outlier? Like, it's tough. It's gonna be really interesting.
It's going to be really interesting, and it's probably also going to be really interesting with what ideas come up to like bend around the rules. Is
for sure
like using a slicing offset. So how do you call it? An XY offset or something like that?
So you have
which
less
is
material.
Which is shrinking the part a little bit, which is helping you with printing it maybe just like 1 or 2% faster. Is that against the rules? Is that in the rules? So I'm kind of upset that I'm not there, because I think it's really interesting to participate in that. Yeah, and to everyone who is attending ERRF, I think they probably need to take their 3D printers with them. They probably can already like practice at home.
Yeah, for sure.
But then
you don't have
it needs to be printed at ERRF.
It needs to be printed there, yeah. But I mean, slicing mesh modifiers are allowed. I believe you can bring your G-code.
Yeah, I would imagine that. Why not?
Yeah, I mean, it could be hand optimized, like actually going in by, okay, this line needs to be that fast. But I would consider that valid if you bring your own G-code.
Yeah, totally. And well, maybe in the end, there are a couple of ideas coming from such a competition that could make it into future 3D printing slicers to make 3D printing more efficient.
For sure. That would be the ideal outcome.
Yeah. So yeah, you're going to be there. Joe, the 3D maker noob, also going to be there?
So, yeah. And of course, the entire US crowd is going to be there. For them, it's just a quick trip.
Well, for the 3D printing nerd, it's quite a way.
It's across the US, but...
It's across the US. It's just across the
continent. He's not even leaving the country, man. Like,
yes, but still a 5-hour flight.
It's true.
Yeah. In which state is the
Washington?
ERRF? It's in Washington.
So it's near Baltimore, I believe.
Cool. Yeah. One of the reasons why I didn't go to ERRF, even though I would have really liked to, is just the fact that I have been flying so much this year, and I kind of need to watch my carbon footprint a little bit.
Yeah, we noted on that before we started.
Yeah.
I'm like way past. But I did sign the lease on an EV last week.
Okay. Cool.
Getting rid of my BMW and getting a Nissan Leaf.
A Nissan Leaf.
Yeah.
Cool. A new one?
It's their show car, basically. It's almost a year old, but it's the current generation. It has ProPilot. That was one of the features I wanted, like the
cool
lane keep. It's like a Tesla Autopilot Lite.
Okay.
Not navigate on auto. It's lane keep active and adaptive cruise control.
Yeah.
Yeah.
So. Yeah, I think that kind of concludes it. So I hope to be back at the Midwest Rep Festival next year, but I think there isn't a date out yet for that.
It's probably going to be around the same time as it was all these past years. So
this is probably going to be the next big 3D printing venue I'm going
Apparently
to.
ERRF is getting pretty big too. I mean, I'm not expecting like Murph levels of crazy, but it should be a fairly decently sized event. And like all the big players are going to be there. So it's like an accepted show now. I mean, they got there pretty fast.
Yeah.
Going to be interesting. My first time there.
Yeah. It's old, but
we've got a lot to
Makerbot. Yeah, we have a lot to catch up. Makerbot was like just promoting their Makerbot method once again with the method ABS, which is supposedly way better than standard 3D printing ABS. And somebody was asking us what we think of that and if we could kind of verify or debunk those claims. So I don't know. What's your call on that?
So, I mean, it's like the general comparison. This is our premium material, and this is generic ABS. I mean, they're just quoting desktop 3D printer ABS, and giving like nice comparisons of like.
They are not even comparing it to their Makerbot ABS, because the Makerbot also uses lots of ABS, doesn't it? Or it's one of the main materials.
What do you mean? What?
The old Makerbots. Isn't the main material you print on those just also ABS, or are they tuned for PLA? Well, whatever. I think you can print ABS on those, and it would have been interesting to do the comparison.
Right. I mean,
because they're claiming higher tensile strength, around 12%, higher stiffness, so modulus of 25%, and higher heat resistance and things like these.
Yeah, it's interesting how they're comparing the heat deflection temperature in like percent. They're saying 15 degrees is 20% higher. Like reference to what?
Yeah, they should have done it in Kelvin. Then it wouldn't have been that much of a difference.
Is it? In Fahrenheit, it would be less. Yeah, so I guess if they want the maximum percentage, if we're referencing 0C as like nothing, so that doesn't make a whole lot of sense. But still, first of all, what are they comparing to? On what printer? On what specific material? On what print settings? Like we both have seen in filament testing that there is such a huge range in how well, like strength-wise, a material can print just by changing a few settings. When they're saying, hey, tensile strength, I don't know if that's layer adhesion or something, but they're also showing, hey, our competitor has delamination in its prints, and the method completes the print entirely. It's just such an abstract comparison, and like there's better and there's worse ABS materials for any. Like, it doesn't really tell you anything.
Yeah. It's I wouldn't even put that it's like bullshit promo, but they are kind of putting their Makerbot method again at a point where it kind of reminds me of the comparisons you see with the Formlabs printers and comparing that to FDM, to horrible FDM. The thing is with the Makerbot method, they have kind of a nice enclosed chamber. They have their own printer, they have their own material, they have their own slicer. So they can tune that material to a point that it is really working well on their machine and also performs really well. If you're buying kind of a standard ABS at your local filament reseller, this material needs to work with a large variety of printers. It needs to work mostly with open style printers. It also has to work with closed printers and things like these. So you can't probably tune it in a way that precisely to one specific application as you do it for something different, for what Makerbot is doing.
That's true. I mean, there's probably no doubt that if the method does everything that they're advertising, it's actually a good printer for ABS. Like,
definitely.
It's closed, it's heated, it's optimized for that. Sure, probably good machine, but how much better is it than say you put a Prusa in a box? Yeah. That's up for discussion.
Yeah,
and actually, I'm looking at this part right now. I'm seeing some artifacts that look like very normal 3D printing artifacts. So.
So the thing is, definitely. The thing is, so we have a kind of professional 3D printer at work, which also has a closed heated chamber. And the thing is, I wanted to buy different ABS filament than the one that you can buy from the manufacturer, just because they sell it for a horrible high amount of money.
Manufacturers tend to do, yeah.
as manufacturers tend to do. But the thing was, all of the standard ABS materials that I had at home, they had, I think, a problem with the heated build chamber. They were curling up and stuff like that because I think they were like tuned in a way that they kind of work better in a cold environment. And in this printer, you can heat up the printing chamber to 100 degrees Celsius. So for ABS, you kind of put it to like 60 degrees Celsius. But this temperature might already be too much for the standard ABS materials that, we kind of know. So they either tuned their process or that material in a way that it works quite well with the machine and it produces beautiful ABS prints.
Yeah.
But I couldn't, and I was really sad. I couldn't reproduce these nice printing results with the standard ABS I was using right here.
Yeah. I mean, that's the thing. ABS is not just one material. Like, hey, you have even a nylon isn't always this. Every polymer has just so many different varieties of it, where it's like, hey, it's been polymerized differently, or it has a different, with ABS, it's actually 3 compounds plus X, whatever that they're putting in on top of that. And you can vary how much of each you put in. Even with PLA, you've got your base blends of PLA that you can get from NGO, NatureWorks. And then on top of that, you add your colorant, your master batch, you add in your elastifiers, you add in whatever else you want. And just because it's ABS with PLA doesn't mean it's always the same material. There's, like you said, they're optimized for different things. Or maybe some 3D printing filaments are just not optimized for anything. Yeah. Or just like the cheapest stuff they could get.
Yeah. So I think to conclude that, I'm really looking forward to see results of the Makerbot method on my own, and maybe I have the chance to see some of that at Formnext this year. Maybe you have the chance to see something at TCT in Birmingham in a couple of weeks.
I think I interviewed them at, not for my channel, but yeah, they probably are going to be there, I'm thinking. One last topic to go. We're working through these. We're getting there.
So, Teaching Tech, Michael.
Yes.
Aussie YouTube fellow posted a video also 1 or 2 weeks ago about non-planar 3D printing. Non-planar 3D printing has been around for a while, but there was I think, master thesis released with a modified version of Slick 3R that can be used to slice a model in a way that the top surface is, that for printing the top surface of the part, the print head is not only moving in X and Y direction, but it also uses the C direction. So real 3D printing.
So it
and the thing
contour.
Is, since he released that video, I am getting tons and tons of comments, and people are talking to me about, oh, what do you think about non-planar 3D printing, and does it help strength, and what do you think about it, and how will that change 3D printing, and things like these. So I think it's a nice method, but you have been trying it on your own, I think. I haven't been trying it on my own because it's only compiled for Linux and things like these. I think it can only be used in a real narrow margin because there are so many things that are limiting this method that it can perform in a way that it would be really beneficial for the prints as we know them today.
Is that a Makerbot joke? Yeah.
So the thing is, and even if you're looking or if you're watching his video, is that he had to remove the fan shroud around his extruder, and you have to get as much clearance as possible that you can use that non-planar 3D printing to a specific angle, and you are kind of limited in that way in the first place. And then geometry also changes it as well. I don't know, maybe you can say a couple of things about the version that you have tried out and your successes or failures that you have had.
Okay, so I did try it out in VirtualBox. Doesn't work. SlickThera just has rendering errors. So I grabbed an old laptop, and set up a Ubuntu system on there, set the entire thing up. Works. I can use it. I can slice things with it. Now, the limitation I found, which is a pretty big, like, hey, we can do non-planar slicing now, asterisk. It only works really with hand-selected models. I've not found a single like organic model, one that I would have actually printed on a normal machine, that non-planar slicing actually did anything for. Like you couldn't even see any sort of deviation from the just regular squarely sliced model. So I mean that's why we're seeing that nice wavy pattern that is quite possibly hand optimized for the algorithm to pick it up. Now you do need to set, you have a setting for how high can the maximum travel be from your highest to your lowest spot in one layer. You do have a setting for the angle. I did get the slicer to produce non-planar top surfaces if I really set those somewhat aggressively to a point where like you'd have to get rid of really everything around your 3D printer's nozzle essentially, including the heater block. So you need one of those old, really pointy. I think Printabody used some of those hot ends, like really slim, really pointy hot ends. No fan shroud because you need that continuous angle up around the nozzle. So that's probably just a limitation of the implementation of that very, very slicer that you can get. That is just kind of lazy on picking up on slightly slanted surfaces and all that, and is on the very conservative side. The other thing that I've noticed is that the algorithm, as it currently stands, only picks up the very top layer of any model. So if you have, do I have an example of anything here? I cannot show you that.
If you have a Benchy.
I actually don't have a Benchy. I don't have a Benchy around here, but I have a Raspberry Pi. This is let me get this right. This is a Model 2, not a Model 3. So if you have, for example, if you have a Raspberry Pi that has like the USB ports poking out, this main surface on the PCB, it could be printed non-planar if you print it like that at an angle. It could be printed with the non-planar method. But it's only going to pick up that very top surface. So let's say these were curved over. It would pick up that, but not this. That, again, is a limitation of the algorithm, of the implementation, I think. So for 3D Benchy, it does not pick up the roof over the cabin that is slanted because there's still something on top of it. It does not print onto non-planar layers, which is all something that could be solved with the implementation of that very specific algorithm. But what still stands is that you do need very good clearance around your tool head. At the expense of part cooling, potentially, but if you design smartly for it, it may work. It may work. It could be something that is actually useful in some cases.
But only in some cases.
Here's the thing, though. It is not meant to, like, if you have a 45-degree angle where you have, like, layers quite finely, where you don't see those discrete layer steps, where it's, like, one smooth surface. It's not meant for that. I think it's really only meant for taking care of those if you have a really shallow inclination, where you have, like, one step every few millimeters, where you actually see each layer step. It's meant to take care of that. And that's where it's needed the most. If you have something steeper, you have a relatively smooth surface and you don't need the non-planarness.
Yeah.
Or also for non-regular surfaces, like the top of a skull or something, where it's actually smoothed over.
Yeah.
Could be nice. I mean, again, the implementation that it can use right now is kind of useless, to be honest. And you have to really, really push it aggressively to do anything. But like our printers can do it, right? Even if you do just an ever so slight maximum height, it's like, what's the distance between the tip of the nozzle and the heater block? That's like 3 millimeters, 4 millimeters or something. I think that would already help a bit. Of course, there's still a lot to figure out, and probably the reason why nobody did it is because it's not easy, or nobody did it so far.
Yeah.
It's nice, but at this moment, kind of useless.
Yeah. I kind of compared it from time to time to the automatic variable layer height thing that I think is implemented in Cura, where the slicer automatically changes the layer height depending on the angle you're printing. If you have steeper angles, it uses
lower layer heights. Yeah. Well, steeper as in
shallower. Yeah. However you want to put it. This algorithm is working very nice for specific models, but everything that gets a bit more complicated and which is not as simple as a chess piece or something like that, it just doesn't work anymore, because at every location of the part you have a triangle that has a kind of a shallow angle. So it would just slice everything at a really shallow angle. And I think this is kind of similar to the non-planar 3D printing, because there, I think it would work kind of nice for a lot of models, but for many, it's just not feasible, because you have all of the time specific parts that could or could not be non-planarly be sliced, and that makes it kind of useless again for the vast majority. So I think it is not something that we see with every like slicer in the future and every slicing operation, that always non-planar 3D non-planar slicing is used, but there could be specific applications and maybe a specific slicer which implements that you can use for a specific model that you're printing.
Yeah. Now, what's popping into my head right now is non-planar actually better than just doing like regular layers, than having, consistent layer spacing? Because if I'm looking at, like, for example, let's say a skull that's printed like this, where like whatever that part in the back is, that's like really round and smooth, what you'd have with non-planar is you get regular layer, and then at the top you suddenly have that jump to, oh, now it's a smooth surface. Wouldn't that be more distracting or more jarring than having just these layers consistently?
So maybe the applications will not be for really organic models, because there it might be a bit distracting. But if you're looking at an aerofoil of a wing, there it has its benefits. So the wing, top of the wing, where you kind of you print the whole top of the wing in.
Typically, if that's the wing, you'd print it like standing up, so you have your air going over it like that. But if you print it flat, then yes, that can definitely make sense.
Yeah. And I think this was actually one of the models that he showed in his master thesis where it was working well. And then we also have the model that Michael from Teaching Tech kind of designed, which is kind of flat and shallow and just has like
a few
tiny inclinations. And there it's working really well, but everything that is a little bit more, it's not working anymore due to the constraints that you have with clearance around the nozzle, and probably also the shape of the nozzle itself, because the nozzle is not just a small tube where the material is coming out. It has kind of a significant flat surface,
which is around 2.5 times the diameter of the bore, typically on E3D nozzles. So it is quite large. So
So you would need to use specifically designed nozzles for such an application, airbrush nozzles and things like this.
Airbrush nozzles specifically are very steep on the sides. Yeah. And I mean, obviously you can only push it so far, because at some point you just, if you do like an 80-degree steep part, like that's not going to do much, just riding up and down that slope. You're not going to be laying material down onto the part. You're just going to be squeezing it past the part.
Yeah, there is a non-planar support algorithm implemented in Pathio, where the supports under a supported surface is the printer prints kind of needles where then the next layer is put onto. This is already implemented in Pantheon, which is, in my opinion, a really, really nice new method of supporting specific areas. And they actually claim that you get way nicer down-facing surfaces with only this kind of needle support that you have
So
there.
that's not... Okay, so you're not printing a non-planar layer, like we just said, as an interface layer where the next part.
No.
But you're moving the nozzle just straight up in Z, and then okay,
you kind of print a sawtooth pattern
right,
at the location where you will have the supports later.
Right. Okay. Yeah. So just that idea of not just having everything forced into a layer, into an XY layer, and just Z being discrete. There's more to it. There's more there.
No. And it's so Michael from Teaching Tech was totally right. I think he started this video with something like, what if I told you that your 3D printer is actually only printing in 2.5 dimensions? Yeah, that's totally true.
Totally correct, yeah. Makes 3D objects, but technically it's just 2.5D.
Yeah. Yeah, all right. I'm excited to see what's coming up there in the future. Maybe there are some other students around to kind of try to optimize or to like just improve that algorithm in another thesis, or even if there might be a slicing company that tries to implement that in a better way in their slicing software to get...
I feel like this is very much a math problem.
Yeah.
to figure out like where can you do what.
I think even just identifying the surfaces where you can use it, it's already interesting to see in the new Prusa Slicer version, the tool that you can use to put your model flat on the print bed, where they somehow analyze the outer shell of a part to identify surfaces that might be interesting for you to put the model on. I think this is I love this feature so much, because in Cura doesn't have something like that at all. The drop-on bed is just never working for me.
That's the automatic one, right?
Simplify 3D has where you can select one triangle, and the Simplify 3D will orientate your model according to that triangle you have selected.
And I think NetFab did it very similarly too. If you do it directly in NetFab, it also has that one triangle thing.
Yeah. But yeah, this is, I think they kind of tackled a little bit similar problems, like having 100,000 triangles and identifying just 10 surfaces that might be interesting as surfaces to lay a model flat on the table.
For Prusa, I think it's, what is it called? Convex shell or something, where it creates a second geometry that encases the first one, but is all flat or convex shapes. And basically it shows you all the plane or all the triangles of that shape. I think that's something that is solved, but like the non-planar thing is just so a mathematician or an actual programmer probably knows more about that. I mean, again, I'm excited about what's coming from this, because this is literally the first version of non-planar slicing that is available for everyone to try out. I don't think there's been a slicer out there that does that yet. So
nope.
We're just seeing the very first version of it.
Yeah. And if you want to try it out on your own, you can download the G-code file that Teaching Tech has created. I think it's on Thingiverse.
Somewhere.
Yeah.
Yeah. And if you want to actually use the slicer yourself, you will need to set up a Linux system and hack in a few command line commands. Not that hard if you've done it before, but not a starter project either. So you need to be somewhat confident with Linux, because the guide that they have has a few plot holes. So you need to be able to work around those. But it's still doable.
It's doable, definitely. All right, I think that concludes the topic, and we should move on to the questions.
Right, we're already at 1.5 hours. Let's do, out of those 3 questions, let's throw one out.
I already threw one out.
Okay.
We're ready for. I will throw out another one.
Let's answer that next time. It's actually, you just deleted that. Okay, I'll read the first one.
Okay.
Jeffrey Reed was asking on, I believe that's on YouTube, right? Hi guys,
yes.
Excellent podcast. And with that said, I have an idea for a YouTube video. Upon watching Stefan's Polymex PC video and seeing his dry box in it, it occurred to me that you guys should do a dry box segment. DIY with humidity sensors and maybe even compare commercial units too. Thoughts?
We did that. So you have a video on a DIY dry box. I have a video on a DIY dry box. We talked about the filler dry inline filament drying unit, I think also
Shortly, yeah.
Once on one of the podcasts. Yeah. So there is a lot of information out there.
Yeah, I mean, the thing that I've not done yet is, I've built the box with silica gel in it and filament spool holders, which is not a big project. But I've not shown like measurements of how dry it actually keeps it. I'm not sure what commercial units are out there. There would be dry box. There's those yogurt maker things.
Yeah. But these are just the dehumidifier.
Right.
Or? Yeah. So
no, they're just heaters, essentially.
Yeah.
Isn't it the drying units, the modified yogurt makers?
Yeah. There are commercial units around. I think one is actually called Filler Dry, which is kind of a rebranded dehumidifier with, I don't know.
The filler dry is the that inline thing.
Is it?
Yeah.
Okay. Anyways, so yeah, it is. So the thing about how are they working and things like these, I have made a video about what the difference in print quality and strength is if you dry, for example, your PETG filament.
Yeah.
So this is out there. You can find that on my channel and maybe even down in the show notes. So in that video, I have compared non-dried PETG filament that was out in my office for quite a while. PETG filament that I soaked in water for half a week, and then really freshly dried PETG filament that came out of my dehydrator. And there is a difference with PETG. It's not as big as with nylon, for example, which gets or just becomes unprintable at specific moisture levels. But keeping your filament dry, and if you have printing problems, and this could even be jams or stringing, drying out your filaments from time to time, even PLA or PETG, can just help a lot.
Very much agreed. As far as how well do the dry boxes work, they work. If you have like a ton of silica gel in there, they keep it dry pretty well. You have to dry it every, year or so. Just throw it in the oven until it turns orange again. And it does the job, does the trick. I'm not sure how much it actually or dries an already wet filament, how much moisture it actually sucks out without heat.
I'd say none at all.
None at all? Okay. So
is my opinion.
That's a possibility, very much. But yeah. What did he do to the next question? It's all black. Keep your filament dry. Dry boxes work. And if you do need to dry them, chuck them in the oven. Make sure they don't melt, and you're good to go.
All right.
Do you not want to answer that next question real quick?
Yeah, we can do
that. Yeah, that's a short one.
Okay.
Yeah. Werner, you just made it really hard to read. I don't know what you did to...
I wanted to... None. There you go.
Okay. Werner is asking, or saying, sponsors are fine. Do you still earn money with YouTube Premium with no ads? Simple answer.
Yes, we do.
Yes, we do. And in fact, from what I've seen, YouTube Premium actually pays better than watching with ads. So you're very much invited to watch our videos if you have YouTube Premium.
Yeah. Unfortunately, I think the YouTube Originals will become free in a couple of weeks. So I hope that there aren't that many people that jump off the YouTube Premium wagon again
Holy
because
you were gone in Japan. You've not noticed this, but do you have YouTube Premium?
I do.
Okay, so you wouldn't notice that at all, but YouTube has, I think 2 weeks ago or so, started doing double ads.
Oh yeah.
On pretty much every video. Plus, I think the interstitials have become way more frequent. At least it feels like it. So pretty much every video you watch, you'll get one like 7-second unskippable one plus one skippable. One of them is usually muted or no audio. So that has been really annoying. So if you want to get YouTube Premium, that might be another incentive to do so.
So you don't have YouTube Premium?
I do not.
You can deduct that from your taxes. At least I'm doing that.
You're doing that? Okay, yeah, I mean, makes sense. But I do want to experience YouTube like the people do. And also, I mean, this is extortion basically from YouTube. Just going like, hey, we're just going to add another ad in front of your video. We'll keep adding them until you buy Premium. I'm not doing that. Like, you can blackmail me like that.
Well, you could still use an ad blocker, which is bad for us, but that's still possible.
Yeah, I fully admitted you. If I ever shown a screen capture of my browser, yes, I do use an ad blocker too.
The thing I was enjoying, the thing why I was enjoying YouTube also on my vacation now is that I downloaded a bunch of videos just in the YouTube app for the plane that I could watch there.
True.
And playing videos in like, how do you say, if your screen is black, that's also sometimes kind of nice if you want to, for example, listen to
just
music
in the background,
yeah. So
okay. So if you guys want to get YouTube Premium, like, we're not going to stop you. We would actually appreciate it. And the last one from David Mulligan. Where can I find resources on matching drivers to motors? Specifically, I would like to know what are the best match for my TMC 2130s. Do all trinamic drivers prefer the same motor type?
Tom, can you please answer that question? Because I don't have a clue.
I don't have a conclusive answer to that as well, or either. My Padawan, who I've taught 3D printing in the last few years, is actually doing some stepper testing right now between TMCs and DRBs and A1 and A8. Just yesterday, you got a 58 millihenry motor, which is extremely high inductivity, and apparently it's working really well with the TMCs. Like the really low inductivity ones would be like 1 point something millihenry. Those are the ones that you're going to find as 2.5 amps typically. And as far as what motors work well with what drivers, I kind of cheated and just looked up what motors Prusa uses with their TMC 2130s. So what they're using is, I believe, a 6.8 millihenry motor with a 1.2 amp or 1 amp rating. So it is on the lower current side. It's a 40 millimeter length motor, I believe. They're using different ones for Z and for XY, but you can basically look up the part number and find all the specs for it. So it's on the higher inductivity side, and there are a few models that somewhat closely match that, and I'll try to link one in the show notes below. Because those work well for the TMCs. Now, there is also that bit where trinamic drivers have that nice feature where you can match, where you can like pre-process or post-process microstepping curves, where you can adjust for, hey, my microsteps aren't perfectly sinusoidal or perfectly evenly spaced, and you can actually upload into the driver a table that will correct for that. So I believe Prusa are actually doing that with the newest firmwares. But of course, as a user, as a builder, you're not going to have that option. You're not going to be able to, probably not going to be able to do that. So yeah, for TMCs, I would say like mid to high inductivity motors with a lower current, rated current. So
cool. Are we gonna see a video about your driver tests?
Once I work through the rest of the queue, and again, it's not me doing the tests. I'm just having him do all of that, and then at the end I'll swoop in and say like, hey, you know what have you learned? Tell me all about it.
All right, cool. I think that actually concludes it for today.
Yay!
We are so long into the podcast already. And
I mean, we had to make up for 4 weeks, so
yeah.
Next one is going to be shorter, and
definitely
not that long of a wait. So yeah, thank you guys for sticking through the podcast. Thank you for waiting so long for this episode.
Thanks for listening. Thanks for your time, Tom.
Yeah, thank you for your time, Stefan. Get subscribed, support us on Patreon, and get YouTube Premium because it pays well for us. Anyways.
All right. See you guys in the next one.
Bye.
Hear you guys. Bye.